Ladies and gentlemen, I'd like to introduce Mr. Prahallada K.N. Mr. Prahallada is the Chief Program Officer at Biesse India, a subsidiary of Italian MNC specializing in woodworking, CNC machines and systems. With over 3 decades of professional experience in manufacturing across India and Singapore, he holds expertise in machine design, CNC machining, and production planning. Mr. Prahallada leads training and development initiatives, establishing advanced woodworking centers nationwide. Coming from mechanical engineering and has an EMBA in marketing, he has advanced diplomas in industrial engineering and management. Mr. Prahallada drives innovation and growth in woodworking industry through his diverse skill set and extensive experience. Today, we are honored to have Mr. Prahallada as a guest speaker, and he will talk on perspectives of machine manufacturing for woodworking industry and green manufacturing. So please welcome Mr. Prahallada.
So today I'm going to discuss on perspectives of machinery manufacturing for woodworking and particularly on green manufacturing aspects. It's a bit technical here because we have two controls actually to exercise, and one is technical control and the other one is administrative control. So and on our machines today we have this thing on sustainability practices. We offer an option called Green Pack. And this is actually embraced by many customers worldwide who actually, even though it's an option, they invest in this because of the green and efficient machining that they get through this entailed through this package. So it's an option. It includes various features to respect the environment and reduce operational costs, dynamic management of electricity and air consumption. And the major this thing is in woodworking, we use a lot of vacuum technologies that are there. Something like gas guzzlers, something like that. We want to have a parallel to it on mainly on our flat table machines. So we need to have an plan to have the optimization of activation of vacuum pumps. So we have vacuum zoning, and for that we have automatic shutdown of vacuum pumps after a period of inactivity. All these things are incorporated in the package, and it is a good welcome sign that many customers are going with this package. And also when it comes to various things that in the manufacturing aspects where we can target certain things, we had a project of coming up with the green PVC vacuum modules. That's the suction cups what we use on our pod and rail machines. So we have some configurations we use 16 pods. In some configurations we use 24, in some we use 32 of these parts on the machine. So here we have started using material called green PVC, which is free of harmful substances, free of heavy metals, and it complies with most of the stringent international regulations. And customers, the good thing is the customers can dispose the vacuum modules as solid waste. So it is clearly mentioned on the bottom of the vacuum pod. You can see this, the green PVC compound marking is there, and which is quite evident that the customers can dispose this without any special this thing needed for the previous modules what we used to do with phenolic. And also coming to the technical aspect again, we have actually started with this thing, that option again, epoxy axis. So it's an interpolating C-axis that was there on the electro spindle, and if you see on the left hand side, this was the traditional solution what we had with a motor reduction gearbox and the gears, and which had many parts here. If you can see, with an external motor and of course a bigger flange to accommodate. One thing is on the machine dynamics part, because this comes on the Z-axis, so this will have a definite this thing bearing on the acceleration and the machine dynamics. So we have actually worked on this, and we spent quite substantial amount on our turnover on R&D projects like this. Not only to have enhanced technical capabilities, but also on the sustainability aspect of reducing the footprint of developing technologies, especially the carbon footprint. So now we have a compact torque C axis, which is not only technically superior solution than the existing one, but also it is very compact, and we also have improved on the machine dynamics. Okay, so it is actually 3 times faster and 6 times more accurate, and this serves better because it is something like the DDM motor what you have today in advanced washing machines with Samsung, LG, like Bosch, like that. Okay, so similar concept. It's a built-in motor. Earlier we were actually having an external motor. So the energy footprint actually for manufacturing, this subassembly has greatly reduced. That is the takeaway which we need to consider going by the green manufacturing technologies. So when it comes to this thing like little drops of water make a mighty ocean, even we go to that minutest details, where earlier we used to have plastic inserts and sleeves to identify cables, and we use a lot of cables in the machines and our systems what we manufacture. So we have incorporated an automatic cable length measurement, cable length, cable stripping, and on other important aspect with this is on the cable itself. Now we have a direct printing mechanism where we have a thermo inkjet printer that is there, which prints directly on the cable. It is not only on the electrical cables, but we also have this printed on our tubes that we use in our pneumatic modules. And with this, we have eliminated the most of the plastic sleeves that were there. You can see on the LHS here, the old system where we had the identifiers, which were small plastic modules that were there. We have totally eliminated this in all across all the machine formats what we are doing. And with this, substantially, we have also reduced the part count as well as the plastic that is there, which finally goes as waste, so that we have avoided with adopting this practice. So the next one is a very important innovation that happened recently on our edge banding machines. So this is actually a hydrogen force system. So it's an innovative solution for perfect zero glue line edge bonding. That is what. And it is something that we can boast of today with 1 liter of water, 1.5 kilometer of edge band panels is possible today. And this is actually ends up with almost a 70% reduction in energy consumption. That's a whopping amount when compared with the previous technologies what we had, and also with the technologies what our competitors have. And also it guarantees unmatched quality on finished products, and also a great edge bonding strength that is there, which is very much essential in high-end furniture that is there. And of course, energy consumption is reduced and maintenance costs are minimized. And this system is one more, this thing is more environment friendly because it doesn't use any glue, but a minimum amount of glue with a special edge banding tape. It will be there on the tape itself. So we use this system actually uses the hydrolysis process to generate hydrogen, and which is used as a sustainable energy. In fact, hydrogen is ignited at that particular point where actually the energy is required to do the banding process. Okay, so and it is definitely lower in maintenance cost compared with other technologies, particularly with the laser technology. And this is actually a breakthrough innovation that was done recently from Biesse Group. And also when it comes to assembly manufacturing systems that what we have, we here in Bangalore plant also, as well as in our plants in Italy. So we have this lean manufacturing systems incorporated, where machines having more footprint are assembled and tested at customer site, while only we actually have the basement unit comprising only of the cutting line tested in the factory. And modular unit assemblies aid in installation and testing on site within a day. So we have this breakup of modules, so that and also we have a thorough process where it can be integrated in the customer site, say within 24 hours. And assembly on rails, which is real-time monitored as with the takt time requirements that are there. And for all the machining lines, it is established. You can see clearly for our edge banding line here, as well as for the CNC line that is there. And lean manufacturing practices resulting in effectively elimination of waste, all the 7 ways, 8 ways what we have in the lean system. So through various, of course, in all stages of production. And of course, the key differentiator in the business today is the software. And here, substantial improvement is there in optimization and utilization targeted towards the material what our customers use, especially with the nesting technologies and the OptiPlanning software what we have for our sizing systems. And proprietary software for optimizing cutting patterns, tool path, and real-time simulation for complex machining requirements. So it is actually happening. Simulation can be we can have in the real time, and all of these are part of our 3D CAD/CAM system, which is proprietary software developed by Biesse. And efficient and intelligent material handling system complementing for the diverse production needs of the customers, say from all the level from basic automation to a very high-end level automation. Even for a batch one processing all the way till mass production, we have solutions, and we have mastered in having systems across the world, across all formats of industries. And an award-winning software was developed on an IoT-based platform. It's called Sophia for services optimization, predictive maintenance, spare parts management, and analytics. In collaboration with Accenture, we developed, and it was awarded during the Ligna. And we have this one integration even in a small-scale manufacturing requirement, where we have a master software which actually have this thing for controlling the operational sequences through various machine centers like sizing, edge banding, and work centers, the machining centers. So where it is actually the master software drives the optimization and the planning, the CADs, as well as the way in which actually the process has to go through. So this is actually controlled. In fact, it's a design come machining software that is integrated as a package towards this thing, mainly targeted towards process automation. Then as this layout shows clearly that within a space of say around 1,200 square meters, we can have a modern digital factory for companies requiring high return on their investments. And it is actually something for customized production, and you can see it's only a requirement of minimum number of operators. And of course, the scalability is also there, and we have the concept of plug and play that actually the customers can integrate when and where it is required for their production and productivity requirements. So the future in the making is actually above Industry 4.0. We have already a lot of platform solutions for Industry 4.0 and advanced manufacturing solutions, and it is Intelligence 5.0. So we have now with the network of collaborative sensors that mainly are for part of predictive diagnostics involving AI and ML, and the advanced solution for simplifying and optimizing work management and productivity requirements with our customers. And one of the group companies that is there with HST has come up with a Wi-Fi connected electrospindle for accurate diagnostics, in addition to improved safety and flexibility in use, which really actually helps in solution for green manufacturing solutions because of predictive possibilities that are there, which will not result in downtimes, and also aids in customer planning for spares. So and there is really a collaborative solution that what they put together, the whole industry is looking, despite the competitive market landscape that is there. 7 world leaders in woodworking machinery industry, and it is spearheaded by Biesse. They have worked together as a team in defining a standardized interface to connect all the woodworking machines that are there. Let it be machine to machine from a supplier A, supplier B, supplier C, and let it be a system that needs to be integrated. So in the earlier, it used to be almost it used to take 3 days to 4 days actually to integrate different technologies and different interfaces and platforms. But now the ecosystem actually with these 7 world leaders in woodworking technologies, they are coming up with this open communication standard for smart woodworking factory. So it takes just 3 hours actually with the plug and play solutions that are there to integrate seamlessly these technologies that are so diverse. Okay, so it is just 3 days were needed actually to interconnect the machines earlier, but now it is just within a matter of 3 hours that can be done. So this is actually a grand vision from the industry as such. So with the big machine makers from the woodworking industry, so they have come up with this initiative in order to say that it not only saves on the customer time, but also on the various resources that are there. And also it is targeted towards the most important factor when you want to modernize on the IoT, AI and ML platforms. The most important thing that comes to mind is the cybersecurity. Okay, so that also adds to the cost and finally to the efficiencies. So I conclude my presentation on the advances that are there in woodworking technologies with perspectives to green manufacturing methods and manufacturing practices what we have implemented. And coincidentally, India Wood is happening right now in Bangalore, and those people who are in Bangalore, I invite them to visit India Wood to have a first-hand experience on the technologies. So wood is good. Thank you very much.
Thank you, Mr. Prahallada, for sharing information about perspectives of machinery manufacturing for woodworking industry and green manufacturing.